Hello and welcome to Pittsfield Community Television's video production training series, Production Foundations. My name is Matthew Tucker and I'm the Engagement and Experience Coordinator here at Pittsfield Community Television. The session you are about to watch is focused on audio basics. We're going to be talking about microphones and cables and how sound works and why all of that functions. And some of the things that I will be speaking about are going to refer back to a session that we did previously on video basics. If you haven't seen that video already, it's a very helpful video to learn the basics of video, and I recommend doing it just so that you've got the reference points for those couple of times that I'll refer back to it. You can watch that here on the Pittsfield Community Television website, or if you're watching on YouTube, an info card should have popped up for you. So during that first session, I talked about how video is an illusion. And we're going to learn that audio is an equal illusion. And your goals for this session in learning the magic of that illusion is you're going to understand what an audio signal is and how to apply that wherever you are, whether you're in a studio or in the field. Learn different types of audio cable and microphone and when to use each of them, and the basic controls of a sound mixer and how to read that information and use it for a production. So what is audio? Like I said, video is an illusion where you're taking a bunch of still pictures and mixing them together and turning them into the illusion of movement. Audio is taking real-life sound, turning it into an electrical signal, and then transforming it back into sound that people at the other end will be able to hear. So you're doing television. Why is audio important? Isn't audio for radio? Well, audio is actually secretly one of the most important parts of video. There's an old adage that television is 51% sound. For anyone who has experience with an older broadcast antenna that could receive analog video signals, you may remember the joys of static. And when you'd end up with some static getting into your signal, sometimes you'd have trouble seeing the video, but you'd hear the audio fine. You might stick around and continue watching a show until the audio cleaned up. However, if that static made the audio unlistenable and the video was fine, you'd probably tune away because the static would just drive you crazy. And the same can be true with modern video. If your audio isn't quality, people are going to disengage from it. They won't want to absorb the content that the video contains, even though video is supposed to be all of these moving pictures and elements. People won't want to engage with it because the audio is bad. So audio is super important. Camcorders and other recording devices are designed to take audio in and synchronize it with video clips. You can have a separate audio recorder, but when you're working in video production, very often a device such as a camcorder or a studio recorder is going to take the content that you have as far as audio is concerned and match it together with video so you have a single consistent product. But there are ways to mess with that, either by recording audio separately and bringing it into an editor and manipulating the audio so it's positioned the way you want it to be, or by disconnecting the audio from video or putting different bits of video on top of it. There's lots of fun ways that you can play with video and audio together.
How do microphones work? Though they have their differences and different uses, they are all transducers, converting sound waves to an electrical signal. The dynamic microphone is the most common used. These work using electromagnetic induction. Sound waves hit a thin diaphragm which causes it to move. This diaphragm is attached to a coil surrounded by a magnet. This magnet creates a magnetic field around the coil. The sound waves hitting the diaphragm are moving the coil, and the coil's movement past the magnet creates an electrical current. This electrical current is your sound signal. Loudspeakers work in reverse. Here the incoming sound signal moves the coil, which in turn moves the diaphragm, creating sound waves.
And that's really the basics to it, what audio is and how it works. We're going to break that down a little bit and talk about some of the practical elements of what that means, particularly when we're talking about equipment here at Pittsfield Community Television. So when you're talking about types of microphone, there are a decent number of different types that exist. However, the ones that Pittsfield Community Television has a lot of, and so we're going to focus almost completely on, are dynamic microphones and condenser microphones. The difference between these two microphones is in the way that the microphone takes sound and transforms it into an electrical signal that gets sent down a wire. Diaphragm microphones are some of the most common microphones out there. As demonstrated in the video, sound vibrates a diaphragm connected to a coil, which then creates an electrical signal using a magnet and sends it down an audio wire. One of the things to consider when you're working with a diaphragm microphone is that sound needs to be louder in order to make the diaphragm move. So the good news about that is if you have a dynamic microphone, you can be in a space that's louder and not get a lot of that background extra environmental noise, because that extra noise isn't enough to make the diaphragm move. The tricky part then is that it needs to be in a situation where the audio going into it is loud or the microphone is very close to the subject, the person speaking. So that is something that you need to consider when you're working with a dynamic microphone, is the physical location that it's in and making sure that it's close enough to the sound to make that diaphragm move. Another element that's useful for dynamic microphones is that they tend to be less expensive and they don't require additional power to function. So you can plug a dynamic microphone into a cable and it'll just work. I have a dynamic microphone here, and it's a little bit tricky to see with all of the protective elements that are on the head of the microphone. But underneath this foam here is the diaphragm that we've been talking about. So if I were to speak into this microphone, the sound would hit this diaphragm and shake it. And there's a small magnetic ring on the inside of the mic that then converts that signal into electrical impulses that then goes into a cable that's plugged into the microphone. So the second most common microphone that you will see at Pittsfield Community Television is the condenser microphone. And I've got a couple examples of that microphone here. And you'll notice that the microphones I have all sorts of different shapes. I'll get into the different shapes in a couple minutes. But condenser microphones, the concept is very similar. Electric or sound goes into the microphone and makes an element inside vibrate, which then generates an electrical signal. The way condenser microphones work is that they have a specially built electromechanical capsule inside them. And that capsule can be either large and super sensitive, or small and super portable. Any range of sort of different shapes and sizes can be created using a dynamic microphone sensor. This is one of the advantages of these microphones. Another advantage of this type of microphone is that it's extremely sensitive and can detect a wider range of sounds than a dynamic microphone. So you can have it in a space where someone is speaking very quietly, or you can get really up close to, or you can be further away from your subject, or you can get a room space and get a lot of audio in. But one of the tricky things is that sensitivity can sometimes be overwhelming as far as the audio signal is concerned. And so controlled environments like a studio tend to work better, or they work really well in the specific tasks that they're designed for. Condenser microphones tend to also be more expensive because that electrical element that's inside needs to be specifically engineered. It's not a mechanical element, it's more engineered, and so it requires more effort to be created. And because it's electromechanical, it doesn't function without being powered. Some microphones that are powered in this way will have a battery that you can plug into the body of the microphone. Many of these microphones will also accept an additional 48-volt electrical charge, which we call phantom power, to function. Cameras and soundboards are capable, when they are told to, using a switch on the board, to send that electrical phantom power signal to power up the microphone. So if at any point in time you have a condenser microphone in the field, you've got it plugged in, you know the microphone is working, it worked yesterday, and you try and use it and you can't hear a darn thing, what's very likely with that microphone is that it's not turned on. So you want to make sure that you're powering the microphone for it to work. We've talked about the way that the microphones receive sound, but another important consideration when you're picking your microphone for whatever your application is making sure that the microphone has a pickup pattern that is useful for what you are recording. So each microphone is designed to do a specific job, and it's designed to collect a certain range of sound physically based on where it is in space. There is a pattern that's indicated on every microphone where the microphone will pick up sound and where it will reject sound. It won't record that sound or won't record it well. Those are a microphone's pickup patterns. It's important to know the general pickup patterns of microphones when you take them out into the field, because if you're using a microphone with a pickup pattern that's not right for your application, your sound isn't going to be the nicest quality. You're not going to record what you want to record, and that will affect the quality of your audio, which, as we discussed before, affects the quality of your video. I have a diagram here of several different common pickup patterns that are associated with microphones. So these pickup patterns are shown on sort of a sphere of what the microphone is able to pick up and reject. One of the most common pickup patterns is the cardioid pickup pattern, named because it's sort of in the shape of a heart. A cardioid pickup pattern is very common for handheld microphones because it is semi-directional. So you can point the microphone towards your subject and it will get solid sound. But if you have that microphone not pointed at your subject, fancy word would be off axis, the sound is not going to be as clear. It's going to sound muffled or strange. So a cardioid microphone works best when whatever the recording element is, in this particular microphone's case, the diaphragm, is pointed right at the subject. There are some microphones, particularly podcasting microphones, which are bidirectional. These microphones have this sort of cardioid pickup pattern on one side and then replicates it on the other side. That way you could have an interview at a table with two people but one microphone and be able to get that quality audio experience from them both. There are microphones that are capable of doing what are called supercardioid and shotgun pickup patterns. Those are microphones that can get audio that's very far away from the microphone, allowing you to get audio that, instead of having to set up a microphone close to a subject, always best if you can put it right by the subject of what you're recording. But if you've got to get on location fast and you've got to get something, or you don't have the freedom to set your microphones up close to your subject, a supercardioid or shotgun microphone is able to have its pickup pattern reach far past the front of the microphone and get subjects in front of it. The only tricky thing about this is that the farther away you get, the more you can get more undesirable audio because it's not able to pick out the thing that you want to have recorded. So you may have more background sound with a microphone like this. But if that's the way you need to get your sound, always worry about getting your sound first, because if you've got no sound, that affects the quality of your content. If you can make better sound, that's always preferred, but any sound is important. Another type of pickup pattern is an omnidirectional microphone. So I'll use my other microphone before to display what an omnidirectional microphone can do. So an omnidirectional microphone's pickup pattern is all around the head of the microphone. So someone could speak to the microphone right in front, or they could flip it over. And as long as the person is in the little bubble that the microphone records, the sound will work. Very often, omnidirectional microphones have a smaller bubble that they cover in order to not have a lot of sound from around it get in and affect it. This is why very commonly clip-on microphones will have a omnidirectional pickup pattern, because that way the microphone is less concerned with how it is attached to the person who's speaking, just as long as the microphone is close to the person's mouth and can pick up the sound well. So we've talked about pickup patterns. We've talked about the way the microphone gets sound out. And I've sort of touched a little bit on it as I've shown my show and tell. But I want to sort of comment on the three major styles of microphone that you're most likely to encounter in a PCTV production environment. The first is the handheld microphone. So the microphone that I've had on the stand here is an example of a handheld microphone. So you would hold on to it, have it do directed sound, be able to speak with it, and point it at someone else and have them speak into it. And as displayed, very often these microphones are put on a stand, either a big boom stand or a stand on a table, to be able to be as close as possible to the subject without someone having to hold it. Another very common form factor for a microphone is a clip-on or lavalier microphone. So a lavalier microphone will usually have the microphone element, the part that does the audio recording, with a clip that attaches to the subject, and then a cable with all of the microphone electrical processing pieces in another box separately. There are modern lavaliers that fit all of this stuff into this clip, and the quality or price can make them restrictive. So most often you will see a lavalier microphone that's sort of in two pieces connected to a cord. The third most common microphone type that you're going to see in the field is a mounted microphone. So these mics, due to their shape or purpose, are always attached to something. So they're on a stand, or they're on a mount, or they're on a boom pole. A good example of this is the shotgun microphone I showed earlier. So this microphone is almost never held by a person. It's usually attached to the side of a camera, or it's on a boom pole in order to get the sound from a subject. So we've talked about the microphones. Now let's get into cables, because the microphone can do all of its magic and convert sound into electrical signals in order for us to be able to manipulate those electrical signals. But it doesn't help us if those electrical signals don't go anywhere. So we have to worry about cables, and we have to worry about cables a little bit more than we do in video. Video, very often, either you're working with a camcorder and all of the elements are contained, or you're working with an engineering crew who is worrying about the cables. So being aware of what video cables do is less important for the average PCTV member and volunteer. But audio cables are extremely important because you're going to be working with those regularly. Whether you've got a camcorder or you're working in a studio production, you're going to be using cables to get your signals from your microphone to whatever's manipulating your sound. So knowing the differences of cables and how they work is almost as important as the microphone. There are two major types of cable: balanced and unbalanced audio. There's also different types of connectors. It's very important as you're getting started in production to get a basic idea of what types of connectors exist, as well as what they might plug into. That way, when you're getting equipment to go set up your camera or set up your sound system, you have all the correct cables you need to hook everything up, because it's not going to help you if you bring cable type A and you needed cable type B in order for everything to function. So the two major types of camera cable are balanced audio and unbalanced audio. Unbalanced audio functions by having two cables in each cable line. There is what's called a hot signal, or the audio signal that's being created by the microphone, and a ground wire. Because you're dealing with electricity, you want to try and avoid all sorts of unwanted electrical elements going through your wire. So there's two lines that are connected in an unbalanced audio cable. These are super inexpensive to make. They're extremely common, but they tend to work best for under 10-foot lengths. And because of that, they're extremely common in home audio systems. And they're probably cables that you have at home and you're particularly familiar with without realizing that that's what they are and that's what they do. So excellent examples of unbalanced audio connectors are RCA connectors. There's an image there, and I've got an RCA cable here physically with me in the studio. So those have a pin that connects in, and just those limited cable elements inside the microphone and the cables. There are also various types of connectors, such as 1/4 inch that you might see on a guitar or a sound amplifier, or a headphone size connector. The way that you determine whether or not an audio connector is balanced or unbalanced, if you've got one of these metal connectors, is you take a look at the tip of the connector and you count the number of rings that it has. Now this connector happens to be a terrible example because it's designed to handle video and audio. So it has 3 rings. It's a little bit of an anomaly for our description. But on the slide that I have, you'll notice that there is 1 ring on the 1/4 inch connector, the one that looks similar to this. That 1 ring, very often at the top, indicates what's called a tip sleeve connector. That splits the ground signal from the hot signal that goes through the microphone. What you'll see more often and what will feel less common to someone who doesn't do a lot of television production is a balanced audio connector. So a balanced audio connector, in order to ensure the quality of the audio that's getting to the other end, adds a 3rd wire into the mixture. This 3rd wire has what we call a cold signal. So how that works is a hot signal will just be the regular audio signal, that electrical impulse that carries the sound. A cold signal is the same thing, but backwards. And the reason that is done is because the audio signals, when they're brought into whatever the recording device is, get brought back together and sort of compared. And if one has junk in it, electrical anomalies, what we would call noise, the recording device can eliminate that extra signal from one or the other because you've got, it's kind of like having a backup on your computer. You compare the two, and whichever one matches is what the audio signal that gets into the recorder. Examples of this are XLR cables. You can see that type of connector there on the slide, and I have an example here in the studio, or a tip ring sleeve connector. And you'll notice that I mentioned the tip ring connector on a 1/4 inch plug had 1 ring up at the top. A tip ring sleeve has 2 rings, and that allows you to separate that cold signal from that hot signal and allows that information to be carried on the wire. Alternately, on an XLR, there are 3 pins that plug into an audio device, and each one has a different audio element: the hot signal, the cold signal, and the ground. So why is this cable differentiation important? As we mentioned, cables are in charge of moving electrical signals from one end to another. And in order to help do that as clearly as possible, they have what's called shielding. There is a layer of material that's designed to keep unwanted electrical signals from getting into those wires in the middle and have the sound be replicated as closely as possible at the other end. That's why it's important when you're looking at audio cables to consider the source and the cost of the cables, because less expensive cables tend to skimp on shielding. So the sound that comes at the other end is less clear than it would have been if you'd spent a little bit more on the cable. But it's also important to know all of this, because if you get a really long, unbalanced cable, it'll start to not sound that good. And that's because, just by the nature of their simple make and the length restrictions on them, you can get a signal through them, but they'll begin to get, it'll sound like static or popping or picking, and they'll go through the microphone, and that'll affect things. But knowing which cable, why all of these cables work is important, because all sorts of things in our world are electrified now. And knowing what cables you're using ensures that when you have those electrified devices in your environment and you have unwanted noise, like the hiss, crackle, pop of a cell phone call coming in, you can pick the right cables and the right positioning in order to minimize the interference you get. And it's also helpful to know that sometimes there's things that you can do that you didn't think of when you were setting your equipment up. A great example happened to Pittsfield community television staff recently. They were setting up for production in the field and plugged their wires in and had a buzz. It sounded like a big old fat bumblebee, but consistent. And that type of sound almost always indicates that there is either something wrong with a wire or there's something wrong with the way things are connected. Well, come to find out, the cable had been laid along an electrical cable. And because the two of them were running next to each other, similar to the old elementary school trick where if you take a metal pin and run a magnet along it, it will begin to have the iron pin begin to magnetize. The electrical signal in the power cable was affecting the electrical signal in the sound cable. So all that was needed to do was to separate the two of them or make them perpendicular so they didn't run parallel to each other and interfere with each other. That got rid of the buzz immediately. So knowing the nature of your cables and knowing what strengths and weaknesses they have, and that you're working with electrical lines and that sometimes electrical devices behave strangely. So doing things like keeping your electrical cords away from your sound cords can be important so that your sound sounds the best that it can. So we've got our mics, we've got our cables. We send that electrical signal through, and a device now takes that electrical signal and makes it into something that people at the other end can hear. One of the most common sort of misunderstandings for people who are not familiar with audio production is the term gain and its relationship to the term volume. Now, volume is something that we're all familiar with. We adjust it on our audio and video devices each and every day. However, volume is not a word that you very often hear in production applications. And the reason for that is because volume is what is considered the end of a signal's path. The person who has a television or a mobile device or an audio device are listening to the audio of your content, they're going to adjust their volume. They're going to turn their TV up or down. But you're not adjusting volume when you're creating the content, because the volume can be adjusted in many different ways on many different devices. The quality of the speaker, the range of volume options on the device changes what the volume is. So thinking about the volume is really hard. Gain is similar to volume in that it increases the amount of audio signal, what one might think as volume, being put through the wires to create your content. But having a consistent gain allows the person at the end to adjust their volume and have it sound right, whereas the volume ends up being a little bit irrelevant when you're doing that initial design process. Because of this, and oddly, the work of adjusting audio on a mixer board or another device that's designed to input audio elements together is visual work. All audio boards will have some sort of what's called a VU or volume units meter. The example that is shown on the screen here is the same type of meter that we have in our production studios. this VU meter will display, even though it's described in volume units, it will display the gain of the electrical signal that's being processed by whatever your recording device is. If the sound is too low, it will be in that area where there's too little signal with the numbers and the negatives. When you have audio that is too low like that, what happens is someone at the end user side will need to turn their audio up. And when they turn their audio up, turn the volume up, it will generate extra noise. There'll be sort of a hiss that will come through because the signal, once it gets to the speaker device, will have to be boosted so much that the electrical noise from the speakers on the other end will begin to interfere with the quality of the sound. So it'll sort of have a hiss. Enough signal is marked in different ways on different meters. This style of meter has an initial red section to indicate that this is where you want that audio to average in. Other meters will signify this as being the point where the meter changes from the color green to the color yellow. Sound in this range will sound the best at the other end. If it goes past that into another red section, or a red section, because some meters like this one have those two red sections, the far red section is the bad spot. Other VU meters will just have a red section. If your audio is getting into that area, there's too much gain. There's too much electrical signal, and it's going to overwhelm whatever is recording it. Too much signal generates what we call overloaded or clipped audio. When the gain is too high, there's too much audio electrical signal being pushed through the equipment that's recording it, and the sound begins to distort. With analog audio, this was a physical process where the diaphragm couldn't move in a way that replicated the sound. And this was often replicated on the speaker side, where the diaphragm would shake so hard that it might damage the diaphragm. The effect still applies in digital audio, and either way, the sound that you get doesn't sound clear. It will grind or crunch, and it won't sound good to the listener. There are times when you will want to do this on purpose. For example, if you're doing audio on an electrical guitar, whenever you hear that sort of grindy, crunchy, classic rock sound, that is a guitar that is on purpose being overloaded. But when that happens, there's usually devices in the middle that are on purpose overloading the signal, but then cleaning it up so that it doesn't damage anything at the other end. So you can do this on purpose, but you tend to not want to, because not only will it sound lousy, but it could damage audio equipment on the other end. Finally, when you're messing with your audio elements at the final step before it gets recorded, you've adjusted your gain, you've made sure it's not overloading. Now you can play with the equalization or EQ settings. EQ settings adjust the range of frequencies that is recorded by a piece of audio. Now, similar to video, where a camera is only able to get a portion of the visual spectrum that human beings can perceive, audio is able to get a portion of the sound that is going into it. It's not an exact ear replication of what is happening. But you can take that audio and shape the frequencies, similar to adjusting the colors of video, by adjusting the EQ. You can adjust the high frequency sounds and the low frequency sounds and even the mid frequency sounds to get a quality of sound that you're searching for. It can be tricky to explain what EQ is because gain is a very objective, clear, there's too much, there's too little, it's just right. EQ is subjective. Someone who's creating the audio is going to feel the EQ is right, or they'll notice that a part of a person's voice is not being replicated clearly. So they'll adjust the EQ to create a sound that's more pleasing to the listener. So there's no wrong way to EQ something. But if you push something too hard, you can end up with some results that are odd. Someone's voice will sound wrong because you've taken out too much of the high or low frequencies from their voice. EQ is almost an art where you are painting with sound and adjusting the qualities of what you're replicating so that you can add something to it more than just the specific replication of a voice. This is one of those things that's really important to sort of illustrate. So I found a fantastic video. This one is based around adjusting EQ for an electrical guitar. So it doesn't give you an idea of how it adjusts things for voice. But I selected this video because it has really clear, defined differences between high, mid, and low adjustment, and you can clearly hear, even if you're not an experienced audio person, what the difference between each EQ adjustment is.
In this video, we'll be looking at equalization settings, also known as EQ. We'll explore how you can use bass, middle, or treble to adapt your sound. All the settings will be set to 12 o'clock except the one we're using. We're going to start with the bass setting. As we turn the dial to the right, we increase the low end frequency of the sound. You can use this setting to create deeper tones. Turning the bass to the left takes away the low frequency. When we turn the middle setting to the right, we increase the mid-range frequencies, sometimes referred to as the mids. Increasing these gives you a richer sound. Again, as we turn the dial to the left, we reduce the mid-range frequencies for a thrashy and gritty sound. Now we'll do the same with the treble setting, and this affects the high frequency sounds. Turning the dial to the right increases the amount of high frequency tones and gives it a much brighter sound. Turning it to the left takes away that sparkle and emphasizes the warmer tones. Once you understand the basics of EQ, you can begin to play around with the settings and find a tone that suits you.
And that's the basics of how audio works, from the sound in the room, hitting your microphone, getting into a cable, getting into a recorded device, and then being integrated into your video. Whether you're doing this in a studio environment, out in the field, or playing with things in editing, these are the elements that are important to know from a theoretical standpoint and from a functional standpoint to be able to create sound. So now you can take these base ideas and build on them and improve the video content that you create through the magic of audio. I hope this series has been helpful, both our video and audio series, combining the concepts that are required for you to understand the basics of why video works, how you can use it, how you can follow the rules and improve the quality of your content, or you can break the rules on purpose and be more artistic and creative in your content and communicate something unusual with your content. However you decide to use the basics that you've been taught, I hope you continue to expand your skills with us at Pittsfield Community Television by volunteering at events and being involved and going to our training sessions where we get to expand on all of this and show you how you can do this with equipment that we have at our facility. So until our next training session and until we see you at the station, this has been Matthew Tucker thanking you for spending time with me, and I look forward to seeing you soon. Take care.